18. Okay, so 18 gave us this graph. So they gave us this equation. So 2x plus 3y is equal to -6. And they asked us to match the equation to the graph. All right, remember you guys, the only way that we're going to do this right now is by turning this into slope-intercept form, which is y equals mx plus b. All right, so I'm going to add a -2x to both sides. So I get 3y is equal to -2x plus -6. Try and keep it in the format of y equals mx plus b the best you can. So don't put that plus -2x at the end. Keep it in this right format. It's not that it's wrong, it's just going to be a lot easier to see. All right, so now I've got to divide everything by 3. So I have y equals -2/3 x plus a -2. So here is my equation. My slope is -2/3. My y-intercept is 0, -2. So the thing is, when we are doing these equations, once we turn them into slope-intercept form, the first thing we're going to look at is your y-intercept, and the second thing you're going to look at is your slope. And if you recognize, they're all exactly the same, just with different signs. All right, so if I take a look at ours, I have a negative slope, and I have 0, -2 as my y-intercept. So these are my only two possibilities for number 18L, because my y-intercept here is my 0, -2. Which one of these has a negative slope? You guys, which one of these has a negative slope? Because our slope is a -2/3. So I've just eliminated B as a possibility because it doesn't have the right y-intercept. All right, so that's not a possibility. So I know it's one of these two. Well, the difference between these two is the slope. Which one of these has a negative slope, Ryan? A, you're done. So you didn't even need to graph these. You just needed to identify the slope, identify the y-intercept, and then go on to these and identify the same thing on those graphs. Elle, does that help you? Awesome. All right, what else can I do for you guys? Giselle? All right, let's take a look at 27. All right, 27 said graph the equation. So I have 7x minus 2y is equal to a -11. Is this the one you're talking about? Awesome. All right, so I'm going to do adding the opposite on it to begin with. I need to put it into slope-intercept form, so I'm going to add a -7x to both sides. So I have -2y is equal to -7x plus a -11. I'm going to divide both sides, or all the sides, everything by -2. So my -2's cancel out there to make a 1. So I have y equals a positive 7/2 x plus a positive, I am going to turn this into a decimal or a fraction only because it's a y-intercept, I can. And this is going to end up being a positive 5 1/2. So are you cool so far? All right. So my slope is 7/2. Remember, rise and run. And then my y-intercept is 0, 5 1/2. Okay, so now I need to graph this. You guys, I need to see all 4 quadrants when you're graphing these random generic problems. Okay. My y-intercept is 0, 5 1/2, and then I'm going up 7 and over 2. So this one, they're not being all that nice to me because it's going to be a really big graph. So I'm going to drop down here. I'm going to drop down here and make my x-axis much lower than my y, on my y there. Okay, so I feel like I want to count by, well, my rise is 7. If I count by 2s, I could probably figure that out. 5.5 is my starting point. That kind of throws me off with counting by 2s. So maybe I'll just count by 1s and just get 1 extra point. That's one of those times that I would be okay with that. So 1, 2, 3, 4, 5 and 1/2. All right, so I have to go up 7 and to the right 2. So 1, 2, 3, 4, 5, 6, 7 over 2. So this would be my graph. I mean, technically you only need 2 points to draw a line, but I'd like to have 3 if I can. Natalie, what did I say? It is 7 over 2. 11 is my y-intercept. That's okay. I'm so glad you're checking me because you know I make mistakes all the time. So yeah, no, my slope was, well, I started with -7x plus a -11, and I divide everything by -2. So my slope is a positive 7 over 2. My y-intercept is 11 over 2. Thank you for checking me, though. Giselle, you've got that look on your face. Why? Okay. So let me make sure I did this right. So what I did, the first thing you do is you graph your y-intercept, right? My y-intercept is 0, 5.5. Are you cool with that? Okay, so I counted by 1s. So 1, 2, 3, 4, 5. Halfway gives me 5.5. Okay, so now I've got to count 7. But I'm starting at 5.5. So I'm going 1, 2. I'm going to my halves. Can you see that? Because I'm starting at 5.5. So I'm just going up to my half marks, counting by 1. Do you see what I'm doing? So 5.5, 6.5, 7.5, 8.5, 9.5, 10.5, 11.5, 12.5. That's going up 7, and then I go over 2. Does that make sense? Okay. Yes. Yeah, but isn't that the same thing as positive 7 over positive 2 when I'm dividing 2 negatives? But yes, of course. So Rita, you definitely could have left this as -7 over -2. And then what I would have done then is I would have gone down 1, 2, 3, 4, 5, 6, 7, and back 2, 1, 2. And that would be on our line still. So it's still the same line, we just went in the other direction. So absolutely you could do that. Okay? And quite honestly, there's our third point. I did one using a positive 7 and a positive 2, and one using a -7 and a -2. There's our third point. So you could also do that to get the third point. Okay, it's a great question. What else can I do for you guys? Carmen? Number 20, of course. So let's just take a look at 20. Okay. So it says describe the error. So first of all, what I need to do is I need to identify here my slope and my y-intercept. Okay? So for me to graph that, that's what I have to do. All right? So for me to analyze this graph, I need to know my slope and my y-intercept from this equation. Well, my slope from this equation is 4 or 4 over 1. As I look at this, I'm like, oh, okay, that's okay. They did that right. Right? They did a rise of 4 and a run of positive 1. All right. But then for this, my y-intercept, remember, it's y equals mx plus b. So this technically is y equals 4x plus a -1. So this would end up being 0, -1. Well, when they did their graph, they used a positive 1. Right? So their error was they forgot that the format is y equals mx plus b. And so for us to change ours into plus b, it's 4x plus a -1. So our y-intercept should have been a -0, -1. Does that make sense? Awesome. All right, guys, put this away, get your notes out. so now we're going to talk about story problems. All right, so today is 11/5. We are still doing 3.5, so 3.5 continued. And we're talking about graphing slope-intercept form. So far we're not looking to, I'm not having you come up with your own slope-intercept form. Eventually we will be doing that from story problems, but they're going to be giving you the equations and we are going to be graphing them, okay? So it's a little bit easier in that respect. All right, so what we're going to focus on today is we're going to focus on comparing equations when the slopes and or y-intercepts are different. All right, that's kind of what we're focusing on today. All right, so I'm going to give you this story problem. This is example 3 from page 183. I know some of you like to know that. Okay. So we're talking about an escalator. All right, so we're talking about an escalator versus stairs. Okay. So it says to get from one floor to another at a library, you can take either the stairs or the escalator. You can climb at a rate of 1.75 feet per second on the stairs, or you can take an escalator that rises 2 feet per second. You have to travel a vertical distance of 28 feet. The equations model the vertical distance you have left to travel. So you need those equations. You're not coming up with them on your own. That's just what the information is. Those are the equations. Please understand what the T means and what the D means. All right, it says, so these equations, as the equations model the vertical distance D you have left to travel in T seconds. Okay? Which is why your slope is negative. All right, because you're taking that distance off of that 28 the more you go. Can you guys see that? Do you guys understand why it's a negative slope? All right, because we're taking that, we're covering that distance and we're subtracting it off of the 28 total feet you have to go. Okay, so what I want you guys doing is I want you guys, oh, I guess I probably could have put this up there. I covered up too much. I want you guys to graph the equations on the same coordinate plane and then answer part B. All right, this is only going to be the first quadrant because you're going to have a positive time and you're going to have positive distance. All right, so you're going to have to coordinate your slopes, figure out your slopes, coordinate your slopes with your y-intercept. These graphs are not going to be small graphs, they're going to be a little bit bigger. This is hard, coordinating that y-intercept with your slope. That's the hardest part. So be very thoughtful while you are graphing this. What would be really smart of you to do to change that first slope? What would be really smart of you to do, Al? Yes, I would change that to x and y. I agree with you. But what about my slopes? I have decimals. What probably is a good idea for me to change that first one to? Rita? I would change it to an improper fraction. That's a negative 1 3/4, which is going to be a negative 7/4. I would definitely change that. Because then you can use it with the other slope on the same graph as negative 2 over 1. That's not a bad idea. You could use it as negative 1.75 over 1. You could do that. But I feel like a fraction's easier. But Elle, I do like your idea of changing those to x and y because I feel like those are the things that we get more common, we get used to, right? How many of you guys are thinking you're going to count by 2's on your y-axis? Yeah, I probably would too. Counting by 1's is going to make a really big graph. But you can still count by 1's on your y, on your x. You don't have to count by 2's on both. Don't forget to label your axes as well with the information. And the units that go with them. I think t is in seconds, right? So make sure you note that that's in seconds. So I will say the hardest part with slope-intercept with story problems really is coordinating the slope and the y-intercepts when two of them are going on a graph. That can be hard. So you only need just the first quadrant. You guys don't take up room doing any of the other three quadrants because it's only in that first quadrant. So give yourself enough space with just that one quadrant. Now, here's the thing. You're going to need those graphs to go all the way down to that x-axis. Because it says, how much time do you save by taking the escalator? For us to figure out how much time we save, don't we have to go all the way down to the ground? I mean, don't we have to go all the way down to the ground? It isn't all the way down to the ground when our distance left is 0. And y is the distance left. Not just distance, it's a distance left. Alright, so you do have to make enough space for this to get all the way down to your x-axis. So don't short yourself space. So figure out how we're going to use our graph to answer part B once you're done. James, I'm so sorry. You didn't need to do that graph. I hate to be the bearer of bad news. That's not exactly the same line. It won't be exactly the same line. Well, it should be exactly the same line because your slopes are different. counting by twos might be part of the problem. But they should not be the same line. Remember, you're counting by twos. Remember, you're counting by twos. If you counted by twos on your x-axis, when you go down 2, it's only one space. So if you're counting by twos on that x-axis, that y-axis, remember, when you go 2, you're only going down 1. And when you're doing 7, you're actually going down 3.5. Does that make sense?
I was thinking about that, but I wasn't sure if you're supposed to.
Yeah, you have to. You've got to account for that you're counting by twos. All right, so let's take a look at it. So on that first one, I'm going to do my escalator in red. So I'm going to go down 2, which is just one space, over 1. I'm going to go down 2, which is just one space, over 1. So now I'm going to go ahead and make that line. So there is my escalator. And maybe I'll do my stairs in green maybe. So down 7. So 2, 4, 6, one more 7, over 4. 1, 2, 3, 4, right? We'll do the same thing. So down, there's 1, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. That's not right. Something's wrong there. So down 7. 2, 4, 6, 7. 1, 2, 3, 4. Down 7. So 2, 4, 6, 7. 1, 2, 3, 4. That's right. Thank you. All right, so there is my graph. It's not as easy as it looks, does it? I mean, you kind of really have to pay attention to what you're counting by. So there is my graph. Questions on graphing that? All right, so part B said, how much time was saved? Taking escalator. How could I use my graph to do that? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 17. How can I use my graph to figure out how much time was saved? Seamus? Excellent. This right here is going to be the difference in time. So I just need to figure out what that is. And it's going to be approximate. So if I take a look at the red is my escalator. So if I take a look at my escalator, my time was, that's 10, 11, 12, 13, maybe 13.5 seconds approximately. How many of you guys would agree with that? All right, if I take a look at my stairs, my x is approximately maybe 16 or 16.25-ish, something like that in there. How many of you guys agree about 16 seconds? All right, I'm just reading off here where our escalator line and our stairs line hit the x-axis because that's when we get to the ground. All right, and so I'm just going to subtract these. So I have 16 minus 13.5, which is going to give me 2.5 seconds saved. Nice job. What was the hardest part of this? What was the hardest part of this, Raphael? Yeah, I mean, you really do have to anticipate how big it needs to be. Because for you to answer it, it's got to go all the way down to the bottom, right? So think about what you're using your graph for with how big it really needs to be. The hard part, I feel like, in graphing these is really coordinating your y-intercept and your slopes to be able to use both slopes of rise over run with your increments on your y and your y-intercept, and it's a lot that goes on with that. It will get frustrating. So just be very thoughtful with how you're graphing this, okay? All right, you guys are good to go. Elle, are you good over there?
No.